Hello dear friends of security applications! For many applications it is necessary to consider machine safety and to implement corresponding safety functionalities. Here in our DigiDemo machine we needed a security door and an emergency stop. Our SIMATIC portfolio in case of our controllers and the integrated engineering in the TIA portal offers the possibility to do this very efficiently. In the following video we show you how this works with a SIMATIC S7-1200F.
The engineering for the safety application consists of two sections. We start with the hardware configuration of the failsafe controller and finish with the creation of the safety program. The application is to be implemented with the failsafe S7-1200. The hardware consists of the CPU 1212FC and the two failsafe signal modules FDI and FDQ. We start with an empty TIA portal project and begin with the placement of the modules. We select the respective CPU 1212FC DC-DC-DC in the hardware catalog and place it by drag and drop into the network editor. In the device view of the module, the failsafe input and output modules are inserted. We have the possibility to either drag and drop them onto any slot or to automatically allocate the next free slot by TIA portal with a simple double click on the module. In the next step, the specific module and channel parameters of the failsafe signal modules are adapted. We first start with the FDI module. The following considerations must be made in advance for the connection of the command device's emergency stop and safe position switches. Number 1. How is the encoder evaluated? Is it a 1 or 2 channel evaluation? Number 2. Is the encoded fed via the module's internal encoder supply, or does the encoder already provide a safe signal? Number 3. Is the default value of the configured discrepancy time sufficient or not? The respective parameters must be set in the properties of the FDI module. The physical input channels are always arranged in pairs in the input mask, but with a 2-channel evaluation they are later considered as only one signal in the safety program. The term 1 out of 2 therefore means that the module combines 2 input channels to 1 safe signal. For the evaluation of the emergency stop, we select a 2-channel evaluation 1 out of 2 with a discrepancy time of 100 milliseconds and use the internal encoder supply. Since we already selected 1 out of 2 above, the second channel is automatically assigned with the same settings. For the evaluation of the RFID positioning switch of the safety door, we also select the 2-channel evaluation 1 out of 2. We increase the discrepancy time to 100 milliseconds and keep the encoder supply on external. The sensor already provides a safe signal with sensor-integrated diagnosis and therefore does not require a monitored supply from the module. All other setting parameters for the channel acknowledgement or input filter do not have to be changed. The default value is appropriate for most applications. For the diagnosis, short circuit protection, the checkmark short circuit must be set for all 16 channels. The variable names for symbolic addressing can be assigned parallel to the hardware configuration. All input addresses of the respective module are listed under I/O tags. We thus define the variable name eStop for the eStop button and the variable name safety door for the safety door. These complete the configuration of the FDI module. The safety-related shutdown of the motor starters is performed with a failsafe output. The default parameters of the module do not have to be changed here. Only the variable name for the output has to be added. For the subsequent application, we need the variable names for start, stop and ACK for the acknowledgement, which we enter in the list of the I/O tags of the CPU module. The hardware configuration is finished now. The next step is to create the safety program. Compared to a standard project, the project structure differs by the Safety Administration Editor, which is shown in the project tree. In the Safety Administration Editor, the central administration of the safety program takes place. The OB 123 calls the main safety FB, which includes our safety program. Here we see the setting of the cycle time, which shows how often the F program is called, the priority, as well as a warning limit for the cycle time and the maximum cycle time that must not be exceeded. We directly start in the main safety module of our F runtime group. On the right, we find under the instructions a folder named Safety Functions. This contains certified components, For eStop, a two-hand operation, muting, a monitored feedback loop, and safety door functionality. We begin with the evaluation of the emergency stop. We drag and drop the eStop module into the first network. The module covers all requirements for the evaluation of the emergency stop. The input parameter eStop is connected with our variable eStop. In this context, ACK NEC means that an acknowledgement is always required when the emergency stop is actuated. This acknowledgement is initiated via input ACK. When the emergency stop is unlocked and ACK is acknowledged, the output of the component Q is set to true. In order to enable a logic interconnection subsequently, we define a static variable for this output and interconnect it with the module output. In the next network, we drag the block for the evaluation of the safety door. We connected two block inputs, each one with a variable safety door, since our protection monitor contains only one safety position switch. The functionality of the ACK NEC input is identical to our eStop module. Again, we need the acknowledgement and a static variable, which we will later use for the logic interconnection. We now have executed the evaluation of the control devices and have to carry out the logic for the safety shutdown of the starters. The safety shutdown logic should be as follows. When the start button is activated, it is turned on safely. When the emergency stop button is actuated, when the safety door is opened, or when the stop button is activated, it is switched off safely. This logic is implemented by the relevant interconnection of the blocks. Therefore, we need a memory element, which we insert into our next free network. We define the variable StatAutoOn that stores our initial state. Thus, we can switch on the status via the start button. When the eStop signal is missing, when the safety door is open, or when the stop button is operated, it is switched off. The output drive is switched at this point via an assignment. But there's a special feature for the safety project planning. When a channel, module or communication error occurs during operation, it is safely switched off and the affected module is passivated. The global acknowledgement for all F modules is performed via the module ACK-GL. Only the acknowledgement button is connected with the ACK. We compile the safety program and the entire project. After the compile, we see in the Safety Administration Editor the listing of the offline signatures. The signatures are unique and relevant for the safety-related acceptance of the plant. The signature changes if a modification is made to the implemented hardware or to the safety program. The signature is also generated module granular. For a more complex project, it is thus possible to retract the safety-relevant modifications based on the module signature. Thus, the engineering of our safety application is completed now. We can save the project and download it to the CPU.
The implementation of safety functionalities with the IA portal is that easy. Good luck realizing your safe machines.
Siemens. Ingenuity for life.